Alright, example 7, find the limit. So again, we're going to find the limit of this function here as x approaches negative 3. So we could graph this, we could use one-sided limits, we could see if direct substitution works. So to see if direct substitution works, you are going to write out the function. Okay, look at the domain. So if we look at the domain of this function, we know x is an element from negative infinity to negative 3, union from negative 3 to positive infinity. So basically x cannot be equal to negative 3, which for this limit, x is approaching negative 3, so direct substitution cannot work. So next what you can do, you can see if we can manipulate this function. So if we manipulate this function, the numerator, we can factor this to x plus 3 all over x minus 2 all over x plus 3. Well, if we reduce this function, this limit could be equal to x minus 2 as x approaches negative 3. Now, the domain of this function, x minus 2, the domain is all reals. So now you can do direct substitution, which would give me negative 5. Something that you never want to do, you never want to do this on a test. You don't want to say, oh, this is negative 3 minus 2 as x approaches negative 3, so this is negative 5. This function and this function are not equivalent to each other, so we can't use this notation here. Alright. Let's do example 8 as well. Okay, again, looking at this limit here, let's look at the function. Let's see if we can do direct substitution. That's always the route you want to go if possible, because it's the easiest. The domain here, x cannot be equal to 0. Well, unfortunately, we're evaluating this limit as x approaches 0, so we can't do direct substitution. Let's see if we can manipulate this function. So if you look at x plus the square root of x plus 1 minus 1 all over x, we could multiply the numerator and the denominator by the conjugate. Hopefully you remember conjugate from college algebra. Okay. So the numerator, we multiply those together, you're going to get x plus 1. When you multiply these together, you're going to get negative the square root of x plus 1. And when you multiply those together, you're going to get positive square root of x plus 1. And when you multiply these together, you're going to get negative 1. The denominator, I'm not going to multiply that out. I'm just going to leave it as x times the square root of x plus 1 plus 1. And then I'm going to simplify here. I'm going to make this x all over x times the square root of x plus 1 plus 1. And then I think you can see here the numerator and the denominator, the x's reduce, so this would be 1 over the square root of x plus 1 plus 1. So now this limit is equal to the limit of 1 over the square root of x plus 1 plus 1 as x approaches 0. Now you want to look at the domain of this. Okay. So there's no way to make this equal to -1, because underneath the square root it has to be positive or greater than or equal to 0. So this will work here. So if we do direct substitution, alright, so if you substituted 0 in for x here, you're going to get 1 over square root of 1 plus 1, which would be equal to 1 over 2. So this is going to be equal to 1 over 2. Again, don't do this. Don't do the limit of 1 over 0 plus 1 plus 1. Okay, that's incorrect. All right.